Okay, welcome to Chapter 10, System Architecture. We spent a lot of time talking about design and what we're going to do and how we're going to get everything. And now let's go ahead and put a system in place with system architecture. This will probably be a fairly long video, mainly because we're in what I have got most time in, and that's architecture. So let's jump into it and see what we can find out. The chapter objectives on here I'll let you read, but the biggest thing we're going to be doing is looking at different system and design networks. And I've got some research I want you to do towards the end. I'm not going to have you do a lot of topological work, although I will want you to understand the different topologies that networks are designed for and everything. So the architecture checklist that I would like you to know is, again, and I've mentioned several of these already, but the choice needs to be on what you're going to be doing. Is it scalable? How's the security? How's the user interface? And all the things we've talked about already. The organizational culture, again, what kind of organization is it? Is it international? So it's got to work. Do you want this to be company-wide? Enterprise resource planning, to look at a structure that does everything inside of an organization, one software system to take care of everything. You may want to Google that and look at it a little bit. We'll discuss it a little bit, but there's a lot of detail out there that you need to understand for this right now. So it really depends on what you're going to be using. Cost is a factor. Scalability I've mentioned already. The integration into the web, whether you are new to the internet or whether it's been around for a long time for you, then you have to be able to integrate and be able to make sure your applications work in web. Those of you that are using Office 360, I hope all of you are, because it's free. Those of you that are using that realize that that's web integrated. All the updates come automatically, and you don't have to change systems anymore. There won't be an Office 13 or an Office 26. It'll just be Office 365. So this is what software is going to right now. It's all web-centric. Legacy systems are always a problem, and I dealt with those when I had my business, and you'll deal with those. Companies have a hard time turning loose some money sometimes to keep their software and hardware components upgraded. Security is a big deal. If you haven't learned anything about security prior to this class, then hopefully during this class you'll have an appreciation for security and what companies do to keep it secure. Systems architecture then and now, you can read these bullets up here. The way we do data storage now is totally different. The way I do data storage is totally different. I've got backup on backup on backup. I use software programs. So everything I do, including this class, all the grades, everything I have gets integrated to the web. So everything is in the web. It's also on all computers. So everything I do is integrated to the web. I don't do any online storage anymore, any on-site storage anymore. I have the systems. I don't use them. I do a fair amount of church work, and I save some stuff for videos and stuff that I do for the church. I keep those local, mainly because I do a lot of tweak to them and everything. And sometimes I'm working when I'm offline. But most everything else I do is online. The mainframe architecture, we've almost come full circle now. We started off, when I started in computers a long time ago, back in the 70s, then it was mainframe and terminals. There were no standalone computers. They existed, but certainly not for users and not for consumers. We had servers and terminals, or mainframes and terminals. We've gone to standalone computers or PCs, personal computers, but now with software, we've almost come full circle. With software the way that it is, soon you will have to have an online or internet connection in order to enjoy any software program. There won't be anything stored local or minimal stored local, just because of what we're doing right now, and I see that coming about. It'll probably take 20 more years to get to where I think it will go, but nonetheless, it is what it is. So the technology is advancing and going along. What you have to do is find your company to be able to keep up with this right now. I mentioned a personal computer, network level evolutions. You have local area networks and wide area networks. If you're in a classroom, you're on a local area network. Inside your home is a local area network. Once you go outside of your home and or your classroom and or your local area, then you go into something called a wide area network or even a metropolitan area network. Let's take a look at that. LAN. This is kind of how my stuff is set up at home. I have multiple clients. My clients, though, are my notebook. I have a couple of notebook computers. I have 3 computers in my home. I have a scanner. I have printers. I have servers. They're all connected by a local area network controlled by me. If I log into Western's network, then I go into what is called a wide area network. And it doesn't have to be outside of the area, outside of the U.S. like your model shows here, but it can be. But a WAN connects LANs. Client server I mentioned already. Pros and cons of client server. Obviously terminals are cheap compared to PCs. They basically a keyboard and a screen and an interface unit. How much money? Gosh, if I was to buy a terminal now, wouldn't pay any more than $100 or $150 for one. You can get a cheap screen for $50, $60, and then a good quality keyboard and then an interface. So not very much money compared to a PC of the same magnitude. But you have to be connected to something called a client server, and then where all the money goes. But you want to make changes to everything, you change the client server as opposed to the way it's done now. Excuse me. Take a look at the different roles that the fat client, thin client design. Get an idea what that means. 2-tier, 3-tier design. You have different types of servers. I won't even go into you have backup servers, you have data servers, you have storage servers, you have servers that translate, you have servers that have operating systems on them, and multiple types of different servers. Here's some designs. Middleware. Let's see, this class is not using any middleware. If this was a CIS 243 class, then we have a product called My IT Lab that uses a Pearson product, and the way to connect Blackboard and My IT Lab is called middleware, sometimes known as glueware, but most of the time I've heard it called middleware. That's kind of a finger pointing problem. If I'm having trouble contacting My IT Lab through Blackboard, and I contact Western, they will say it's Pearson's problem, and Pearson will say it's Western's problem. Typically it's a middleware problem. It's the interface that goes between the two systems. Again, you have to do cost-benefit analysis with everything that you do. It has to be scalable, has to make sense. Performance issues, a lot of finger pointing goes on when whose problem it is. Typically what I've seen with my experience has been when you have performance issues, it's typically been bottlenecks. Bottlenecks are caused by a component failure or a poor design. Most of the time, poor design. Bottlenecks need to be compensated for. The impact of the internet, I could spend 2 days talking about the impact of the internet. Obviously, you all are able to take this course because of the internet. whereas otherwise you may not be able to. Cloud computing, everyone's familiar with that now. I can remember when I first talked about cloud computing a few years ago, then that would draw a lot of raised eyebrows because people just didn't understand that. We know now that the cloud and the internet are the same. Web 2.0 is, when it first came out, it said, well, it's much faster than Web 1.0. Well, that's not really the case. Sometimes Web 2.0 is slower. It's more collaboration than anything else. If you want to look at Google Docs or any other kind of web sharing where you collaborate with someone, then that is Web 2.0. It's becoming more to the semantic web of what we're doing. And now we have an iOS, an Internet Operating System, and no, that's not the same as Apple's iOS. E-commerce architecture, the benefits of in-house solutions. The flexibility is the biggest issue that I can think of. I'll let you look at this. Again, I have a lot of slides, so I'm going to try to get through this to keep this thing around 20 minutes. E-commerce architecture, different service. You have an application service provider. Your Office 360 would be provided by Microsoft, which is an ASP. Other ASPs offer full-scale services once you log into them. We do a lot of online processing. That can be a bottleneck depending on your PC. If you have an old, slow PC, then that can have a problem. If you have a slow internet connection, then that can be a problem. Take a look at the processing methods. I have discussed online processing before. If you remember back in the first couple of chapters, we talked about transaction processing systems, or TPS. And then this gets processed through an ATM. Batch processing is still here. What happens is companies sometimes set up a batch process after hours. They do all the transactions during that day because the internet is boggled with speed. It's got choke points, got problems. They will wait and process maybe at 1 o'clock in the morning. If you notice, when you do your updates, Windows recommends doing your updates at 2 o'clock in the morning. Why is that? Well, because you may be downloading some large files, and then that would take time. And sometimes the internet is not fast enough in order to make this happen. Point of sale is another processing method. Companies do this. It's been out for a long time. When I had my business, I had a point of sale system then, and this was, 25 years ago. So it's been a long time since I started my business. And point of sale, they work well right now, going from a terminal all the way through. Open systems interconnection depends on what kind of OSI that you have. It's how data moves from one to another. Now, topologies I mentioned before. Topology is configuration, depends on how this is out. We have two types of topologies, physical and logical. The physical topology, if you have a classroom of computers, they are set up on a BUS configuration. The other situations, if you set up, I'm trying to think, if you're on cable network, you're set up in a ring configuration, which means you access a common device. That's why your internet gets so slow at night, because everybody's on it and you're sharing data. So topology is important to set up so that your network can function. And I'll go into a little more detail in a minute. Hierarchical network, you can read. Bus network is what I just mentioned. You have a server, department servers, workstations, and peripheral devices. Typically, an office would be set up in a bus configuration. What's important about a ring configuration is data flows only in one direction from the device to the next, which means if you look at the model right here, if the ring gets severed right here, if this person kicks the cable out of its connection point, then this could cause an entire failure of everybody else's network. So that could become a problem. A star network has one, I'll show you in a minute, I've got a slide coming up. So it has one main network, then a mesh, everything's connected to everybody else. So you could terminate one right here and everybody else would still operate. This is a star network. Notice you have a server. All of these report to the server. Kill the server, these all go down. Same thing with this right here. Problem would be if you kill this server, not only do you lose this, then you lose this, because these are dependent upon this is dependent upon this. That is a star configuration. You can see the ring here. Author said in your book says it flows in one circle. Sometimes you have something called a self-healing ring. You have another line in here, so if this line gets cut, then the data goes in the other direction. This is a bus network set up with a department server, and then the PCs are all on this. This is terminated here. It has to have a termination device located. This is set up on a mesh. Everything is connected to everything. And you can see where everything is connected to everything. So if you take one of these out of the picture, then everything else still functions and operates. Except the way this is set up, it's going from computer to computer. This is not commonly done. This is a logical network. Physically network, you would have to go through the switch of some way. You just can't run one computer to the other. You can, but you need to put a crossover cable and a couple of other network cards in here for this to work. Commonly not used this way. It normally goes through the switch even on a mesh configuration. So the network devices, you have routers. Routers connect network segments, period. Modeling tools, Visio. When you're using Visio, you'll be using this to get a couple of small diagrams out. I'm not looking for you all to become experts in Visio, but you have access to Visio and Project. You're going to need both of them to satisfy this class, or at least to get a decent grade in the class. I want you to download both of them, use both of them, and then they're yours as long as you're a student. The routers, you can see what the router connects the internet to all this stuff right in here. You have a switch. It used to be called a hub. And now we use switches to, or it used to be connected with a hub. But now this switch is intelligent. It knows when traffic is trying to come, and it kind of is a traffic cop. Here's a wireless network. I would say most of us have wireless networks now. There are still some homes where you have to be plugged in, but with the smartphones and today's activities, then most of the time you have a wireless network to connect up. The 802.11 is the standards that you're using. That is not all the standards. That's just standards for the local wireless LANs. Other standards, if you had a metropolitan area network or something else, then you would have a different standard right here. The 11 came out as 11 megabits of speed, 5.5 each direction for the wireless. I'll let you read about this. We all enjoy Bluetooth right now. I can't imagine life without Bluetooth, and you probably can't either. Again, I can remember when Bluetooth was developed, it wasn't very popular because it didn't work well. You had to have, the proximity was only about 2 feet away. If you got any further, it didn't work well. A lot's been corrected since then. Now Bluetooth can operate across the room, and it's doing quite well. WiMAX never quite made it. It's not used much anymore, mainly because of our 4G and 4G LTE and soon to be 5G networks. Okay, I'm not going to spend any time on your systems design. You can see that right there. The completion, what has to happen is you When you get all this done, you go through, it gets approved by management, it gets approved by users, and everyone looks at this right now, and then you present what is taking place on what you will do. So the chapter activities. You can read your activity. The first one will be a purchase. Here are just 3 sites. There may be more sites. In fact, I know there's more sites to where you can find this first bullet that I'd like to satisfy. Again, I want about a half a page of good narrative. The second part up here, you're looking at business mortality rates. Here are some places you can go. There are more. Please give about another half a page right here, and then that will be it for this right now for this part of this chapter summary. Again, we're starting to put things together and present those. You're looking at selecting an architecture, why you would select it. Your chapter does an excellent job of telling you why you would use what to maintain scalability. Are you going to use ERP? If the company is large enough, why, of course, because everything is in one package and nothing has to be configured to operate with something else. You have thick clients and thin clients, and then of course, with the presence of the internet, that changes everything from the way it used to be and allows us to work better. The last slide up here is the way a network is configured. You need to have different configurations for different designs for what you're trying to do, or usages, not designs, but usages on this right now. So that's it. Again, this chapter, I tried to really cut it short. I could talk for a lot longer than you'd care to listen about network architecture. So that's it. Good day.